Good evening everyone. So today we are going to discuss another questions from Acer Green, and this is from oxidation and reduction general chemistry. So look at the STEM information. It is saying many organic compound undergo oxidation reduction, which is called redox. So simple thing is that redox means oxidation and reduction both. This involve a change in the oxidation number of the carbon atom. So you have to look at the change in the oxidation number of carbon. Change in oxidation number of carbon, not any other atom. Okay. One method of calculating these oxidation number is follows. So look at the start, the oxidation number of each carbon atom is assumed to be 0. So during the starting of the any chemical equation, you have to assume a carbon has a 0 oxidation number. Second, a bond to another carbon atom does not change the oxidation number. Look at here. Suppose this is carbon-carbon bond. So the oxidation number of this carbon will be 0 as well as this one is also 0 because they are bonded to the same atom. Okay. Each bond to an atom that is more electronegative than carbon. So look at here. Suppose you have AB bond and I am saying electronegativity of A greater than B. Okay, so A will be -1, B will be +1 like this. If suppose we have a like this A double bond B and again I am saying electronegativity of A greater than B. So multiple bond has multiple effects. So this is -2 and this is +2. If we have a triple bond, this is -3 and this is +3. Clear? Any doubt? So here these three information you can see. The first case more electronegative, so suppose A is more electronegative, so -1. And then second less. This is quite simple. If A is more, it means B is less. Okay, so you can say +1. Now look at the question 14. So let's discuss 14th. So it is saying by calculating the oxidation number of all the carbon atom in each of the following reaction, determine which one is a redox. So redox is what? Change in oxidation number of carbon. So if you look at the option A, right hand side we have CH3OH. So the bonding of CH3OH is like this. You should know the basic things. Okay, this is the bonding of CH3OH. Now figure out the oxidation number of carbon. So look at here, oxygen and hydrogen. Oxygen is more electronegative. You can see the electronegative elements are fluorine, oxygen, nitrogen, chlorine and bromine. So oxygen is here -1 and hydrogen is +1. Clear? Same thing you can look at the carbon and oxygen. So oxygen is again -1, carbon is again +1 this time. Now we have to consider carbon and hydrogen connectivity. So hydrogen are less electronegative than carbon. You can see less electronegative elements. We have hydrogen, phosphorus, iodine. So we can say here this is +1, so carbon is -1. This is +1, so carbon again -1, again +1 and again -1. So this carbon has 1 plus and 3 -1 charge. So plus minus cancel out. Only -2 is left. So this carbon is -2. Clear? So carbon here -2. Now look at the CO. Look at here, C and O. We don't know it's double, triple or single. Supposed to be single bond. Tell me which one is more electronegative. You can see the information. Oxygen is more electronegative than carbon. So oxygen is -1, carbon is +1. If it is double bond, oxygen will be -2, carbon will be +2. And if it is triple bond, oxygen will be -3, carbon is +3. Overall, this carbon will be positively charged. Make sense? So this carbon will be positive. And this carbon is negative. So there is a change in the oxidation number of carbon. Clear? So option A is the right choice. Make sense? Because we have a change. One is a positive value in the left and we have a negative value in the right. You can check any options as well. Like suppose we are going to check the D one. Let's discuss D. The left is CH3Cl. Look at the smart approach. What is a smart approach? This carbon has hydrogen are less electronegative. So look at the bonding pattern. One is more electronegative element and three are less. Less, less, less. Clear? Look at the right hand side, CH3OH. And look at this carbon bonding. This one also have the same thing. Oxygen is more electronegative. So one carbon more electronegative and all the three hydrogens are less, less, less and less. So same bonding pattern, it means no change in oxidation number. So D is wrong. Clear? Same thing you can apply with the B option as well. We have HCOH and HCONH2. H, C double bond O and OH. Look at this bonding and there is another one HC double bond O and H2. This is my carbon. You can see same bonding pattern again. Hydrogen, hydrogen common, CO, CO common. One is more electronegative, one is here nitrogen also more. So same bonding pattern, it means no change in oxidation number. So B is wrong as well. Clear? And same bonding pattern in the CO as well. So let's discuss D. Question 15th. So here, according to the rule listed above, the oxidation number of a carbon atom that has only one carbon atom bonded it can be. So look at here. Carbon has 4 valency in which one is fixed. Now rest is 3. Clear? So carbon-carbon change will be always 0. So now look at the conditions. Case 1. If we are going to keep all the 3 valency with the most electronegative element, suppose we have fluorine, all the 3. So what should be carbon's oxidation number here? All the 3 fluorines are -1, so carbon will be, here all the 3 are -1, so -3, overall it should be +3. Clear? -1, so +1, -1, again +1, again -1, again +1. Can you see? So overall +3 charge. Now the next case, case 2. Suppose all the 3 are less, suppose hydrogen. So here they are all +1. So +3, so carbon will be -3. Clear? So the range is what? +3 to -3. So +3 to -3 in option A and C. So B and D is wrong. Now we have another condition, case 3rd. Suppose here I am going to keep 2 fluorine and 1 hydrogen. So -1, this is +1, -1, again +1, and this is +1, this is -1. So you can see 1 plus minus cancel out, carbon is +1. So this is +1. There is another condition, case fourth, the last. Suppose 2 hydrogen, 1 fluorine. So -1 +1, +1 -1, +1 again -1. So you can see +1 plus -1 cancel out, opposite charges same number, and -1 will be what? Wait. So +1 -1, +1 -1, and this -1 is a +1. Yes, so +1 -1 cancel out. So you have only -1 is left. Clear? Make sense? Again, you can see here. I said this carbon has, in this case I keep 2 fluorine. Now we are going to keep 2 hydrogen and 1 fluorine, okay? And this is carbon. So fluorine is -1, so carbon is +1. Clear? And this hydrogen is +1, so carbon is -1. And this hydrogen is again +1, again carbon is -1. Makes sense? So overall the net charge will be what? +1 and -1 cancel out. -1 is still we have, so it should be -1. So range is +3 to -3, and we got +1 and -1 as well. So odd numbers. So answer will be C, any odd integer from +3 to -3. So this is from Redox. Again, there is no background information, but I am telling you background information is important, but this STEM is quite easy for us. But in the next few questions, suppose I think Acer red or purple, I think red one, they have some questions from Redox, which is very important as well, because there is a oxidizing agent, reducing agent as well, and in that case you should know some background information. So thank you so much for watching this.